In winter 1944 airfields in southern England hummed with 8th Air Force preparations led by Lieutenant General James H. Doolittle. The 355th, 4th, and 357th Fighter Groups received 100/150 grade aviation fuel for trials. This high-octane blend pushed Packard-Merlin V-1650-7 engines in P-51B Mustangs to 72 to 75 inches of mercury, surpassing the prior 67-inch war. Emergency limit. The number that matters is 444 miles per hour, true airspeed at 20,800 feet, achieved by clean P-51Bs under strict test conditions. Mechanics adjusted carburetor stops, checked fuel purity, and logged valve wear to counter detonation risks at higher boost. Pilots training over East Anglia reported sharper climbs and quicker acceleration in simulated dogfights, the Mustang's silhouette cutting through icy contrails. Luftwaffe pilots encountering these escorts over Germany noted faster closures and steeper climb angles, misjudging dive speeds as level flight gains. Ground crews worked late, ensuring engines ran cleanly under the new fuel's demands. This shift set the stage for deeper raids, where performance would face brutal tests against German interceptors. The spring of 1944 saw the air war over Europe reach a relentless pitch as 8th Air Force under Lieutenant General James H. Doolittle pressed daylight bombing campaigns deep into Germany. B-17 Flying Fortresses and B-24 Liberators struck industrial targets in cities like Schweinfurt, Regensburg, and Berlin, facing swarms of Luftwaffe interceptors. The P-51B and C Mustangs, flown by groups such as the 355th and 357th, bore the brunt of escort duties, tasked with shielding bombers across ranges stretching 600-plus tensors to 750 miles of combat radius at 26,000 feet with drop tanks. German squadrons, including Jagdgeschwader 2 and 26, operating from bases in northern France and Belgium, deployed Bf-109, G6 and FW-190, A-8 fighters exploiting altitude bands from 15,000 to 30,000 feet to break bomber formations. These interceptors, piloted by veterans, aimed to exploit any gap in escort coverage, forcing Mustangs into grueling dogfights across a wide vertical spectrum. The introduction of 100/150 grade fuel, now in broader use by mid-1944, gave the P-51 a measurable edge. At 75 inches of mercury, the Packard-Merlin V-1650-7 engine delivered climb rates several hundred feet per minute higher than at the standard 67 inches, shaving critical seconds off the time. To reach 30,000 feet, pilots reported tighter turn recoveries after high-speed passes, allowing them to regain energy faster and maintain position above German formations. This was no theoretical gain. Fewer bombers fell when escorts could climb quickly to disrupt interceptors. The fuel's higher octane allowed sustained high boost, but it demanded precision. Crew chiefs at bases like Leiston and Debden adjusted fuel mixtures and monitored cylinder head temperatures to prevent pre-ignition, logging darker spark plug colors as a sign of richer combustion. The constraint was maintenance engine overhaul intervals shortened when routinely using 72 to 75 inches of mercury to address valve seat wear. German pilots debriefing after missions described Mustangs closing with unnerving speed, their climbs outpacing the Bf-109 G6, which managed roughly 408 miles per hour at 22,000 feet. The FW-190D9, equipped with MW-50 water methanol injection, could reach 432 miles per hour, but struggled against the Mustang's newfound agility below full throttle. Height. American pilots briefed on the fuel's limits used the improved acceleration to dictate engagement terms, diving from high altitude to scatter German formations, then zooming back to regain position. This tactical flexibility compressed the Luftwaffe's interception windows, forcing defenders into reactive maneuvers. Logistics underpinned this edge. 150-grade fuel required careful distribution, prioritized for escort groups over shorter-range P-47 Thunderbolts. Supply chains from British refineries to forward airfields were streamlined, ensuring steady deliveries despite German efforts to disrupt Allied logistics. Maintenance crews under pressure to sustain sortie rates worked long shifts to keep engines within tolerances. They tracked detonation margins and valve conditions, noting increased wear under prolonged high-boost use. These challenges were offset by results bomber losses dropped as Mustangs controlled the skies more effectively. Each mission refined tactics as squadrons learned to exploit the fuel's benefits in the chaotic, high-stakes environment of deep penetration raids. The Luftwaffe's response was to shift tactics, focusing on lower-altitude ambushes where their fighters could leverage surprise. Yet the P-51's enhanced climb and acceleration countered these moves, allowing escorts to reposition quickly and maintain offensive pressure. By late 1944, the 8th Air Force had integrated 150-grade fuel into standard operations with technical instructions, emphasizing altitude-specific boost settings to balance performance and engine. Longevity. The fuel did not transform the Mustang into a mythical machine, but it sharpened its tactical edge, enabling pilots to outmaneuver German fighters in the critical moments that decided engagements. The air war's momentum tilted further toward the Allies, as the P-51's ability to dominate the fighter band reshaped the battlefield. The Packard-Merlin V-1650-7 engine heart of the P-51B Mustang defined its dominance in 1944. Its two-stage, two-speed supercharger, paired with 100/150 grade fuel, unlocked manifold pressures of 72 to 75 inches of mercury, surpassing the prior 67-inch war emergency limit. Engine overhaul intervals shortened when routinely using 72 to 75 inches of mercury. This fuel allowed a clean P-51B to reach 444 miles per hour, true airspeed at 20,800 feet, with a service ceiling of 40,500 feet and an absolute ceiling near 41,200 feet. Compared to the Bf-109 G6, which achieved roughly 408 miles per hour at 22,000 feet, the Mustang's advantage lay not in raw speed but in climb and acceleration. Tests showed gains of several hundred feet per minute in climb rate, reducing time to 30,000 feet when cylinder head temperatures were kept within limits. Ground crews at English bases such as Leiston and Steeple Morden played a critical role. They calibrated carburetor stops to handle the higher boost monitored fuel mixtures for pre-ignition risks and checked spark plug color to ensure clean combustion. Luftwaffe pilots analyzing engagements over Germany reported Mustangs climbing faster to disrupt their formations, often mistaking high-speed dives for sustained level flight performance. The P-51B's airframe's sleek and low drag amplified the fuel's benefits, particularly below full throttle height, where acceleration and vertical performance dictated tactical outcomes. Pilots noted the engine's crisp response after the blower shifted at 20,000 feet, enabling sharper zoom climbs and quicker energy recovery after firing passes. The fuel's introduction, formalized by 8th Air Force in mid-1944, came with strict technical instructions. Maintenance logs recorded increased valve seat erosion under sustained high boost, prompting careful monitoring to maintain sortie rates. Compared to the FW-190D9, which reached 432 miles per hour with MW-50 injection, the Mustang held a clear edge in the high-altitude Escort band. Its ability to sustain 75 inches of mercury gave pilots tactical initiative, allowing them to dictate engagement pacing. The Luftwaffe, scrambling to counter this shift, found their interceptors outmaneuvered in the vertical as Mustangs leveraged climb rates to control positioning. This technical refinement, grounded in fuel chemistry and disciplined engineering, tilted the air war's balance without altering the airframe's core design. At airfields like Leiston and Debden in 1944, 8th Air Force pilots briefed on the P-51B's enhanced performance with 100/150 grade fuel. The Packard-Merlin V-1650-7 engine, running at 75 inches of mercury, delivered climb rates several hundred feet per minute higher than at 67 inches. Pilots described a livelier aircraft, responsive off the merge with zoom climbs that positioned them above German formations in seconds. Test pilots emphasized precise throttle control to manage cylinder head temperatures, avoiding detonation during high boost runs. Engine response after the blower shift at 20,000 feet was immediate, enabling tighter turn recoveries and faster energy regain after firing passes. The number that matters is 600 to 750 miles of combat radius at 26,000 feet with drop tanks. Ferry range with two 108-gallon tanks could reach roughly 1,400 to 1,600 miles. Ground crews played a pivotal role, removing external racks to minimize drag and adjusting carburetor stops for the approved boost. They tracked spark plug color, noting darker hues from richer mixtures, and monitored valve seat wear to maintain reliability. Overhaul intervals shortened when routinely using 72 to 75 inches of mercury. Pilots valued the ability to re-engage quickly, cutting Luftwaffe interception windows. In combat, Mustangs dove from 30,000 feet, scattered Bf-109 G6 formations, then climbed swiftly to reset the fight. Luftwaffe pilots debriefing at bases in northern France and Belgium cursed Mustangs that outclimbed their 490A8s, mistaking their vertical prowess for impossible level speeds. Briefings emphasized that maximum speed gains were modest, 444 miles per hour at 20,800 feet, but the real advantage lay in acceleration and climb. Pilots exploited this to maintain offensive pressure, diving on interceptors, then zooming to regain altitude before Germans could reposition. This cadence disrupted Luftwaffe tactics, forcing defensive maneuvers. Crew chiefs, working late under canvas tents, logged detonation margins and valve conditions, ensuring engines withstood the fuel's demands. Each sortie refined tactics, as pilots learned to balance the Mustang's newfound agility with its mechanical limits. The 150-grade fuel sharpened their edge, enabling escorts to dominate the high-altitude band and protect bombers more effectively, tilting the air war's momentum toward the Allies. By mid-1944, Luftwaffe pilots from Jagdgeschwader 2 and 26 flying from bases in northern France and Belgium faced a transformed aerial battlefield. Their Bf-109 G6 fighters topped out at 408 miles per hour at 22,000 feet, while the W190D9 with MW50 injection reached 432 miles per hour under optimal conditions. Against them, the P-51B Mustang, powered by 100/150 grade fuel at 75 inches of mercury, climbed to 30,000 feet in about 10 to 11 minutes under test conditions. This climb rate, several hundred feet per minute, faster than at 67 inches, allowed American escorts to dominate the high-altitude band critical for bomber protection. German pilots reported Mustangs diving at speeds exceeding 500 miles per hour, a performance they misread as sustained level flight capability, fueling exaggerated perceptions of their speed. The Mustang's edge was most pronounced below full throttle height, where acceleration and vertical performance outpaced German fighters. P-51. Bs, leveraging their Packard-Merlin V-1650-7 engines, reset engagement swiftly, zooming back to altitude after attacking Bf-109 formations. Luftwaffe pilots cursed Mustangs that outclimbed their few 190A8s. Maintenance logs from 8th Air Force fields showed overhaul intervals shortened when routinely using 72 to 75 inches of mercury, but the tactical payoff was undeniable. Bomber losses dropped as escorts controlled. Engagement pacing. German squadrons stretched thin across shrinking territory, shifted to low-altitude ambushes, hoping to catch Mustangs off guard. Yet the P-51's enhanced climb and energy retention countered these tactics, allowing pilots to reposition and maintain offensive pressure. Logistics strained both sides. The Allies prioritized 150-grade fuel distribution to escort groups, ensuring steady supply from British refineries to forward bases. German MW50 systems, while effective, were less reliable with limited stocks, hampering sustained operations. The Mustang's combat radius 600 to 750 miles with drop tanks enabled deep penetration missions stretching Luftwaffe defenses thin. Field reports noted the P-51's ability to re-engage multiple times per sortie, compressing German interception windows. By late 1944, the Luftwaffe struggled to match the Mustang's tactical flexibility as American pilots exploited their aircraft's performance to dictate terms. The fuel's impact, subtle yet decisive, amplified the Allies' air superiority, forcing German commanders to rethink their dwindling options. The notion that 100/150 grade fuel transformed P-51B Mustangs into 490-mile-per-hour machines was a Luftwaffe misconception, not fact. Clean airframe tests at 75 inches of mercury confirmed a top speed of 444 miles per hour at 20,800 feet, far short of the exaggerated claim. German pilots, shaken by Mustangs diving past 500 miles per hour from 30,000 feet, mistook these bursts for sustained level flight performance. The true advantage lay in operational dynamics. Climb rates improved by several hundred feet per minute, cutting time to 30,000 feet, and sharper acceleration allowed pilots to control positioning. Overhaul intervals shortened when routinely using 72 to 75 inches of mercury. This enabled Mustangs to disrupt Luftwaffe formations, re-engage swiftly, and compress interception windows, often before German pilots could reposition. Luftwaffe reports from 1944 gathered from bases in northern France and Belgium described Mustangs climbing with unnerving speed to foil Bf 109 G6 attacks. The P-51's combat radius, 600 to 750 miles, with drop tanks, ensured escorts could loiter over targets, maintaining pressure deep into Germany. Maintenance crews at Leiston and Debden logged increased valve seat erosion under sustained high boost, yet kept sortie rates high through meticulous tuning. The fuel's chemistry did not rewrite aerodynamics, but enhanced tactical flexibility, letting pilots exploit brief windows of advantage in the chaotic fighter band. American squadrons under Lieutenant General James H. Doolittle refined these tactics by late 1944, using the Mustang's climb and acceleration to secure air superiority. German misperceptions stemmed from the P-51's ability to dictate engagement tempo. Diving at extreme speeds, then zooming back to altitude, Mustangs appeared faster than their tested 444 miles per hour. The Luftwaffe's few 190D9, reaching 432 miles per hour with MW-50, could not match this vertical agility. The fuel's real impact was in reducing bomber losses by enabling escorts to reset fights quickly. By 1945, the 8th Air Force had honed this edge, proving that disciplined engineering and pilot skill, not mythical speeds, shifted the air war's balance. The 150-grade fuel was a force multiplier, amplifying performance where it mattered most in the fleeting moments of combat. By March 1945, the 8th Air Force under Lieutenant General James H. Doolittle curtailed widespread use of 100/150-grade fuel as operational needs shifted and supply standardization took hold with engine wear among the concerns, with ground crews reporting accelerated erosion in the Packard-Merlin V-1650-7 engines. Air superiority over Germany was largely secured, as Luftwaffe squadrons depleted by relentless Allied campaigns struggled to mount effective interceptions. The P-51Bs tested top speed of 444 miles per hour at 20,800 feet, paired with its combat radius 600 to 750 miles with drop tanks, had proven decisive in protecting B-17 and B-24 formations deep into enemy territory. The fuel's true contribution was not headline speed, but enhanced climb rates and acceleration, enabling pilots to dominate dogfights and reduce bomber losses significantly. The 150-grade fuel, introduced operationally in mid-1944, allowed Mustangs to climb several hundred feet per minute faster, reaching 30,000 feet swiftly to counter Bf 109 G6 and FW1 190D9 interceptors. This tactical edge, honed through disciplined maintenance and pilot skill, tipped countless engagements. Crew chiefs at bases like Leiston and Debden logged meticulous records balancing performance gains against increased wear to sustain sortie rates. The fuel's chemistry, paired with precise throttle management, enabled escorts to dictate engagement tempo, disrupting Luftwaffe tactics and ensuring bombers reached targets like Berlin and Schweinfurt. By 1945, the air war's momentum had shifted decisively, with German fighter groups like Jagdgeschwader too reduced to scattered defensive operations. As jet aircraft emerged on the horizon, the 150-grade fuel experiment faded its lessons, absorbed into post-war aviation design. The episode underscored how incremental engineering advances, fuel octane boost settings, and rigorous maintenance could amplify an airframe's effectiveness without altering its core specifications. Pilots, reflecting on 1944 to 1945, credited the fuel for tightening their tactical control, allowing them to outmaneuver German fighters in critical moments. The P-51's legacy endured not as a mythical 490-mile-per-hour demon, but as a precision instrument of air dominance shaped by the interplay of technology and human skill. The air war closed with the Mustang's reputation cemented its performance, amplified by a fuel that proved decisive in the skies over Europe.